A Rubik's Cube is one of the most recognizable puzzles in the world. It has colors, faces, rotations, and hidden structure. At first, it looks like a toy, but underneath the toy is a group of transformations. Every twist moves pieces around, but the whole object stays coherent. Now here is the question that started bothering me. What would happen if we built something like a Rubik's Cube, but instead of square faces and plastic pieces, we used geometry itself? Not just ordinary geometry, but higher geometry, surfaces, seams, symmetries, and analytic structure. That is the idea behind what I call the seed. The seed is a mathematical object I have been developing as part of my zeta space framework. But before getting into zeta functions or advanced math, I want to explain it in the simplest possible way. Think of the seed as a strange geometric machine. It has 4 main surface sheets. These sheets are not flat squares like on a cube. You can imagine them more like curved football-shaped orbifold surfaces. They are glued together along a central seam graph, which I call gamma. This seam graph is the nervous system of the object. It is where the sheets meet. It is where information gets passed from one region to another. And it is where the object starts behaving less like a static sculpture and more like a machine. So instead of a Rubik's Cube with 6 colored faces, the seed has a richer color system. There are 4 sheet colors and 3 seam colors together. That gives a color structure. And 7 is not random here. The 7 colors can be organized like the Fano plane, which is one of the most beautiful incidence geometries in mathematics. In the Fano plane, every line contains 3 points, and the relationships between the 7 objects are highly symmetric. So the seed is not just colored for decoration. The colors encode relationships. They tell you which sheets and seams interact, which transformations preserve structure, and how the object can move without falling apart. This is where the Rubik's Cube analogy becomes useful. A Rubik's Cube has Lego moves. You can rotate one face, then another, then another. Each move scrambles the cube, but it also preserves the deep structure of the puzzle. The seed has something similar. It has a finite group of piecewise isometries, which I call, you can think of as the move system of the seed. These moves act like rotations or twists, but they act on the glued geometric object, the sheets, the seams, and the color structure. So the seed is not just a shape. It is a shape with legal motions. That is why I think of it as a Rubik's Cube for higher geometry. But there is another layer. When you twist a Rubik's Cube, you move colored pieces. When you twist the seed, you are moving geometric and analytic data. You are moving relationships between surfaces, seam graphs, spectral information, and eventually zeta, theoretic information. This is where the object starts to feel like an alien computer. In an ordinary computer, information is processed through bits, circuits, and logic gates. But in the seed, information is processed through gluing, symmetry, color, and motion. The sheets are like memory spaces. The seam graph is like a communication network. The piecewise isometries are like operations. The Fano color system is like an algebraic rulebook. So the seed is not computing in the normal electronic sense. It is a speculative geometric computer. A machine where the operations are not and, or, and not, but seam, gluing, rotation, descent, averaging, and symmetry. That is the big idea I want to explore. Can geometry itself behave like a computational device? Can a puzzle object carry real mathematical structure?
Can something that looks like a toy also be a serious model for thinking about zeta functions, spectral theory, and topology? For me, the answer is yes. Or at least, this is the direction I am investigating. In my zeta space framework, the seed is meant to organize several kinds of data at once. It has a topological part, because sheets are glued along a graph. It has a geometric part, because the sheets carry metrics and symmetries. It has an algebraic part, because the moves form a non-commutative group. And it has an analytic part, because spectral quantities, theta functions, and Melling transforms can be studied on this object. That may sound abstract, but the visual intuition is simple. Imagine taking the logic of a Rubik's Cube and replacing the plastic cube with a living geometric foam. The object can be turned, it can be colored, it can be unfolded, it can be averaged over its symmetries, it can carry waves, heat, winding modes, and spectral data. That is the seed.
And this is where I want to build it physically. I do not want this to stay only as equations on a page. I want the seed to become a real puzzle, a desk sculpture, an educational object, and maybe eventually a large public artwork. Because some mathematical ideas are easier to understand when you can hold them. A child can understand a Rubik's Cube long before they understand group theory. The toy comes first, the algebra comes later. I think the same could be true here. A person might first see the seed as a beautiful, strange sculpture. Then they notice the colors. Then they notice the seams. Then they realize there are legal moves. Then they realize the object is not arbitrary. It has a hidden mathematical language. That is the experience I want to create. The seed is my attempt to turn a deep mathematical framework into something visible, movable, and maybe even playable. A Rubik's Cube teaches group theory through the hands. The seed could teach higher geometry through the hands. And if the deeper zeta space theory is right, then this object is not just a metaphor. It may be a real geometric engine, a way of organizing symmetry, spectral information, and zeta theoretic structure inside one compact object. So when I say I built a Rubik's Cube for higher geometry, I do not mean I built a better puzzle. I mean, I am trying to build a bridge between toy and theorem, between sculpture and computation, between symmetry and analysis, between something you can rotate in your hand and something that might help us think about some of the deepest structures in mathematics. That is the seed. And this channel is where I am going to build it, explain it, animate it, and eventually turn it into something real.